Okay, what I've drawn on the board is a voltage divider circuit. It's very similar to what we've had before, where we have two resistors in a series circuit. Now the reason we call that a voltage divider is, remember, in a series circuit the voltage across each individual resistor can be different, and it will be different if those resistances are different. And you can see that I have resistor A at 390 ohms and resistor B at 470 ohms. The voltage drop across both of the resistors is 9 volts, but the question is, what is the voltage across resistor B? Now, why are we doing this, Mr. A? Sometimes I get this question from students that want me to make everything relevant for them. Well, say, for example, you had some sort of a power supply that you plugged into the wall, and you wanted to plug one of these was a USB port where you could power something with a USB, and the other one was like some other sort of a battery charger that required a different voltage. You may have some of these appliances at home where you can plug in multiple things and charge them, but they take different voltages, right? So you want to be able to, you want to know that you have a certain voltage going to these devices that you plug in here, and then you want to know that you've got another set voltage that you're plugging into those other devices. Different devices have different voltage requirements, so this is how we design the circuit. So the question is, what is the voltage drop across B? When you are solving these kinds of problems, the first thing that I want you to do is to draw the circuit and then label everything that you know. That's the equivalent of writing down all the given information. There's a lot of given information right here. It's given that it's a series circuit, you're given the resistance, you're given the voltage. In order to solve this type of problem, what you need to do is, first you need to determine the current that is flowing through the entire circuit, your I total, if you will. And then once you know the current, you can determine the voltage drop across this resistor because you know the current flowing through it and you know its resistance, right? So let's go ahead and start filling in some of this information. I need the voltage drop across B. That is my unknown. Well, do we have an equation for voltage? Yes, let's see. Maybe I need to write my little cheat thing over here. That current flow is equal to the voltage divided by the resistance, but what I'm looking for is voltage, so the voltage across B is going to be the current going through the entire circuit multiplied times the resistance of resistor B. Okay? We know what the value of resistor B is. What we don't know is the current. All right? The current flowing through the entire circuit, our I total, is equal to the voltage across the entire circuit divided by the resistance of the entire circuit, our total. I think your book says equivalent. I'm going to use those two words interchangeably: total resistance, equivalent resistance. So our total, remember, in a series circuit, is simply the sum of the resistance. So let me plug in some numbers here. It's going to be 9 volts divided by 390 plus 470. Order of operations here. Make sure you put big fat parentheses around the denominator. Why don't you pause the video and see if you get the same answer that I do. Okay, what'd you get? First of all, let's add 390 and 470, and let's get 860. So that's 9 divided by 860, and then that's going to equal 0.01. Now remember, that's just our current in amps. We need to plug that number in over here, 0.01 times the resistance of RB. This is what we're trying to figure the voltage drop across, is equal to 470. And that should give us an answer of 4.9 volts. That video ended without really a conclusion. And here's what I want. I need to drive a point home. We calculated the voltage drop across resistor B. What I want you to do right now, and you've done it already for resistor B,
Do it for resistor A. What do you get for the voltage drop again for resistor A? Well, it's simply the current through the system, through the circuit, and since it's a series circuit, it's going to be the same current as it was before, but this time you multiply it times resistor A with what we're trying to figure out. So you take the same current as before, the point, maybe you should do the 0.0104. All right. Okay. That's a good number. Maybe a little too many significant figures. Can I round that to 4.1? Okay. Now, look carefully. What is the sum of the voltage drop across these two resistors?
0.8.
4.9 and 4.1 equal?
9.
Ding, 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 ding. All right. So to conclude this video, what I want you to write in your notes is the sum of the voltage drops across the resistor in a series circuit equal the source voltage. That has to. In this case, the battery voltage, 9 volts. 4.9, 4.1, voltage drops sum up to be 9 volts. That's what I wanted to say.